All right, we're going to look at just the truth value of a particular statement dealing with percents and discuss why or why not certain statements would be correct. So let's just jump right in. The first one, Leonardo got a 10% raise at the end of his first year on the job and a 10% raise after another. His total raise is 20% of his original salary. In other words, are we okay with adding 10 plus 10 to get 20? So I would say think about that for a moment, and the answer is false. That's actually not true. 10% of the first year is going to be a certain amount, but after he's gotten a raise, we're doing 10% of the old salary plus the part that he got a salary increase on. So it's not just a straight up 20%. We can't just go 10% of his salary plus 10% of the new salary does not equal 20%. Sorry, does not equal 20% of his original salary. Those numbers don't translate over. Jung and Dina paid 45% of their first department store bill of the $620 and 48% of the department store bill of $380. They paid 45 plus 48% equals 93% of the total bill of the 1,000. Can we get away with adding those two up? And that's also false. We've got two different percents. So 45% of 620 plus 48% of 380 does not equal, so we've got two different totals that we're finding percents of, and I can't just add all the numbers up and say that that's got to equal 93%. Now we could go in and calculate this and actually get numbers on that, but the way percents work, we're not just allowed to add the percents up and get 93 of a new total and expect that to be mathematically sound. There might be an instance where it's true, but for the most part, when you got two different balances, you can't just add them up like that. Bill spent 25% of his salary on food, 40% on housing. Bill spent 25% plus 40% or 65% of his salary on food and housing. Okay, this one actually is true. Okay, and the reason why this one worked and the other ones didn't, it's the same amount. 25% of his salary plus 40% of his salary. So it's the same number that we're finding the percent of. So in this case, we can definitely add the percents together. It kind of goes back to like terms. So that actually is a true statement, mainly because we're finding this the salaries match. So you want to think of it like you're factoring out the salary and you did 25 plus 40. That's fine. But that actually is a true statement. In border town, 65% of the adult population works in town, 25% works across the border, and 50% is unemployed. Everyone in town is exactly in one of those categories. Okay. Well, first thought to consider is they're basing the percent off the same amount. It's the same population of the town. So what do they mean by exactly one of the categories? Well, have we accounted for everybody? So does 65% plus 25% plus 15%, does that actually equal 100%? So that's kind of a question mark until we actually do the math. Okay. Well, I'm already going to cry foul because I can see 3 5s here, and there's no way that's going to add up to give me a straight 0 at the end. But let's actually figure out what this is equivalent to. Let's see, 65 and 25 is 80, 90 percent plus 15 is unemployed. So we currently have 105%, which does not equal 100%. So in other words, the percents are just off. They've actually accounted for everybody, plus people that don't even live in town. So that's just false, just because you can't even have that. You've got 100% of everyone. So just because you've got categories that add up to 105 doesn't make it true. In Clean City, who comes up with these names? All right, in Clean City, the fine for various polluting activities is a certain percentage of one's monthly income. The fine for smoking is 40%. For driving on a polluted car is 50%. Oh, that's harsh. And for littering is 30%. Mr. Schmutz committed all 3 polluting crimes in one day and paid a fine of 120% of his income. Is that even possible to do that? Well, let's kind of set up an equation here. So he just was crazy. So he did 40% of his salary plus 50% of his salary plus 30% of his salary. Okay. So if I, in essence, factor out all of the salary statements, let's see, so if I do 40% plus 50% plus 30%, sorry, that disappeared there. Just factor out the S, the salary component, I do end up getting 120% of the salary. Now, is that okay that he paid 120%? Sure. It's a very stiff fine. That just means he owed more money than he actually made in that given day. But hopefully they're discouraging people from doing those crimes, I guess, which is sort of the intention there. So that actually is a true statement. Although mean, it is actually true. Okay, now in talking about percents, that allows us to introduce money. Students always like to talk about money. Any age likes to think about that. And so we're going to talk about interest. And so we'll kind of pose a question and then we'll have to define some terms. So suppose we borrow $6,000 for a bank at a simple interest at a rate of 5% to be paid off in 2 years from now. Okay, how much would we have to pay back? Well, at this moment, we really don't know what simple interest is. So let's look at a definition. Simple interest means that the interest will only be computed on the principal for a stated amount of time. So we just pay interest on the amount that is borrowed. So the formula for simple interest is I equals PRT. Okay, and then so we got to define a couple of terms here. So P stands for the principal or amount borrowed. R refers to the annual interest rate, and T refers to time. Okay, and so I in this case is going to be the amount of interest. If I actually want to calculate the total amount that I pay off, the total amount, which we're going to call A, the total amount would be the principal plus the interest itself. So substituting in our little formulas there, so A equals P plus PRT, and then I can factor out this P, so 1 plus RT would actually generate the full amount. Okay, so principal times 1 plus RT. All right, so let's go back to our original question here about the loan. Suppose we borrow $6,000. What would we have to pay in interest, and then what would we have to pay back? So I equals PRT. P in this case is $6,000. R is 5%, which we need to convert that into a decimal, and T refers to as 2 years. So in this case, I would be 6,000 times 0.05 times 2. And again, this is just going to tell us the amount of money that we are paying back. So 6,000 times 0.05 times 2. So I get $600. That's how much I'd have to pay back. So the total amount that I pay back is P times 1 plus RT. So 6,000, 1 plus 0.05 times T. Now I realize that if we, so it looks like a minus, that if we take the 600 interest we're owing, we add that to the original amount, we're going to get 6,600. But I just want to convince you that this formula actually does also do that same task. So 1 plus 0.05 times 2 times the 6,000. And so we get the 6,600 that we talked about earlier. Okay. Vera opened a savings account that pays simple interest at a rate of, and we're going to do 5 1/4% per year. If she deposits $2,000 and makes no other deposits, find the interest and the total amount after 90 days. Okay, so there's a lot of tricky things going on in here that we have to kind of convert this into. Alright, so we want the interest, and then we also want the final amount. So let's start with that. The interest is I equals PRT. So the principal in this case is 2,000. The interest rate is 5 1/4, which is, sorry, got to keep the symbol here, which fourth in terms of a decimal is 5.25%. So without the percent, then it's 0.0525. And the time is 90 days. Well, we need to kind of convert that into in terms of years. So what fraction of a year is 90 days? Well, that's 90 over 365. So that's what I want to use in my formula. So 2,000 times 0.0525 times 90 over 365 will tell me how much we paid in percent for the year, or how much interest we paid. So 2,000 times 0.0525 times parentheses 90 divided by 365. Close and equal. And so we end up paying about $25.89. Okay, so then we can use the other formula to calculate the total. Now I realize we can just add the $25.89 on top of the 2,000, so we should get $2,025.89. But it's always a good idea to show that, you want to show how each of the formula work. So the total amount, 1 plus RT, so that would be 2,000, 1 plus 0.0525 times 90 over 365. And so that's what I want to type in my calculator. Oops, clear that. 2,000 times parentheses 1 plus 0.0525 times parentheses 90 divided by 365. So close that and close that. Okay, so look about what I wanted to say. That looks pretty good to me. All right, and it's exactly what we said was going to happen. So it's the $25.89 plus the 2,000. So $2,025.89. the total amount we have to pay off.